All right, so here we go for problem number 8 right here. Now, let's go over to our conversion chart. First thing I want to take care of is really important for problem 8 is understanding quantity versus rate, or power versus energy. Over here in problem number 8, it says an electric clothes dryer has a power rating of 4,000 watts. Assume a family does 5 loads of laundry for 4 weeks. Assume each dryer takes 1 hour. Find the energy in BTUs. Now look, it's going from a power rating to BTU. So it's going from power over to energy. Now if I look here, so here's energy, here's power. These two, you can't go one to one. Okay, you can't, there's no straight conversion unless you include a component of time. So there has to be power and time combined in order to get total energy. So let's go back down to our problem. So we have the power at 4,000 watts, but now we need to include time. 4,000 watts means how many watts of energy it uses per hour. Now we need to figure out how many hours it's running. Okay, we could do some dimensional analysis with this, but this is pretty straightforward. 5 loads of laundry times 4 weeks. So how many loads of laundry? 20. Okay, well, how long does each load take? 1 hour, so that's 20 hours. All right, so now let's go back to our paper right here. Remember, label. I know my answer. Listen, I know my answer. So look, I'm boxing my answer right now, so I don't forget. BTU. This is my answer. Has to be in BTU. So let's start setting up dimensional analysis. 4,000 watts. Okay. How long does it run for? 20 hours. Okay. Now, I want my answer to be in BTUs. Right now I have watts and hours. I need to get rid of that. So I need to go over to my conversion chart and see, is there anything that I can use to get rid of the watt and the hour? Well, there's my watt hour right there. I can get rid of it. See, there's nothing else that I can, like I can get rid of watt, but then it's going to change it into joule seconds. But that's not what I'm going for. Like I said, I need to switch it over into an energy problem, because right now it's like it's in the realm of power. So I'm going to look at, okay, I can use this watt hour right here, but look, there's another watt hour right here. So I could use either of these two, and this is the beauty of math. There's more than one way to solve a problem. So I could use this one and go to joules, and then from joules, I can go to BTUs. Or I can go from watt hours to kilowatt hours, and then go from kilowatt hours to BTUs. So it doesn't matter. It's going to arrive at this. It's going to take you to the same answer. So I'm going to do this variation right here. So this one says, okay, 1,000 watt hours equals 1 kilowatt hour. So 1,000 watt hours equals 1 kilowatt hour. Watt gets canceled out. Hour gets canceled out. I don't want it in kilowatt hour, so I got to get rid of it. Okay, and I want it to turn into the BTU. Is there a conversion? Yes, because I just saw it. That's right here. So 1 kilowatt hour to 3,412 BTUs. So 1 kilowatt hour to 3,412 BTUs right here. Cancel, cancel. That's going to give me my answer right there. Done. All right, so now this is just, and there's different ways to do this, okay? So like you can just do straight multiplying, like you can do like 4,000 times 20, and then do divided by 1,000, and then multiply by this again. I personally, like I said, I'm going to use scientific notation, so this is 4 times 10 to the third, times 2 times 10 to the 1, divided by 1 times 10 to the third, times 3.412 times 10 to the third, because it's going to move it out 3 decimals. 1, 2, 3. Okay. Remember, I do these separate pieces right here. So first I'm going to do all the multiplication. So 4 times 2, that gives me 8. Okay, divided by 1. So divided by 1 is still 8. This is on top, so 8 times 3.412. So 3.412 times 8. That's 16. Carry my 1. That gives me a 9. That's 32. Carry the 3. 24, 25, 26, 27. like that. 3 decimals, 1, 2, 3. Okay. Now I take care of my exponents. 3 plus 1, because it's multiplication. That's 10 to the 4th. This is a division problem, so I take 10 to the 4th minus 10 to the 3rd. That's 10 to the 1. Now this is up here as a multiplication problem. 10 to the 1 plus 10 to the 3rd. This is times 10 to the 4th. Like that. This is not in correct scientific notation, because scientific notation has to be less than 10. So I'm going to plop this over 1, which is going to change my decimal to a 5. So this turns into 2.7. I'm going to round 3 times 10 to the 5th. BTUs. That goes there. And that's it. Another way I could have done this is, look, 4,000 divided by 1,000. Okay, that's 4 times 20. 4 times 20 is 80. Okay, so this is like just another sub problem here. So 80, right? 80 times 3,412. So like I can do all this. So 0, 0, 0, 0, 16, carry the 1, 8, 9, 8, 32, carry the 3, 24, 25, 26, 27. Drop down some zeros, 0, 6, 9, 2, 7, 2. BTUs. Like, oops, sorry. Let's do it all off screen. BTUs, like that. I want to change the scientific notation. 1, 2, 3, 4, 5, and boom. 2.73 times 10 to the 5th. Same as that one. Same as that one. Math works out well. Boom. Done. All right. What about problem B? And again, this is taking me long because I'm doing like multiple versions of all the, like I'm doing scientific notation, I'm doing this one. It's not going to take you 7 minutes to do this. So I'm just showing you, again, kind of multiple ways to do this. And there's still more ways. These are 2 of a lot of different ways. Okay. But if you're running into some problems, it's just me explaining it one of 2 ways. All right, coming back over here. Now it's asking in part B. So look, I'm gonna on my AP test. See, I'm gonna separate it out. This is part A up here. Again, making sure they understand that's part A, and then I'm gonna label this bottom part as part B. Okay, so for part B. Now it's asking, what is the total energy used in kilowatt hours? Okay, well, let's go back. Let's take a look. So here I have a certain number of BTUs, 2.73 times 10 to the 5th. But guess what? It's asking for kilowatt hours. I already did that right here. I already got it, basically. So like I can go back to the problem and say, like, okay, well, let's do kilowatt hours again. So look, it's 4,000 watts. Okay. How long did they run it for? 20 hours. Okay. And I want it in kilowatt hours. So I need to cancel out the watt and the hour with a watt hour. Okay, got that. And then I want to change it into a kilowatt hour. And we already got that. So it's like 1,000 watt hours equals 1 kilowatt hour. Watts, watts. Hours, hours. 4,000 times 20 times 1,000. Again, we can do all this math, again, but it's going to lead us to the same answer, 80 kilowatt hours. Answer to B. Done. All right, what about C right here? Now C is just saying, okay, well, what's the total operating cost? If it is 0.15 kilowatt hours, or sorry, if it is 0.15 dollars or 15 cents per kilowatt hours, well, that's easy. You're just taking 80 kilowatt hours and you're multiplying it by 0.15 dollars, and that should give you roughly around $12 for the total cost, somewhere around there. Again, if your number is a little bit off, not a big deal.